This video is on factoring quadratics. We're going to do 3 more examples of factoring using the macab method. So on our next example, we have x squared minus 5x plus 6. First step is always your GCF. The smallest number on here is a 1 because your a is a 1 value. That means our GCF will have to be a 1. And not all of these terms have a letter in it, so our GCF is just 1. What we're going to look at now is also what is our a value, since we do not have to divide by anything. Our a value is 1. That means that we do not have to use the grouping box to finish our problem. So we don't have to use the grouping box. We will use our half box, but not our grouping box. So I'm going to go ahead and go to the half box. We're going to do our mac, which is our a times c. So our a value is 1, and our c value is that positive 6. So 1 times 6 is just 6. Then we're going to do on the side, we have our b value, which is that negative 5. We're going to list out everything that multiplies to 6 without the sign, so it's just 1 times 6, 2 times 3, and that's it. Now we look to see if any of the numbers can add to that negative 5. So 1 and 6 can go to the negative 5 if the 1 is positive and the 6 is negative. The 2 and the 3 can also go to the negative 5 if the 2 is negative and the 3 is negative. So actually both of these can add to the b correctly. But remember, you have to make sure that they can mac and ab together. So let's go back to our mac. Can a positive 1 and a negative 6 multiply to a positive 6? They cannot. So even though these will add correctly, they will not mac correctly. So these are gone. A negative 2 times a negative 3 will multiply to a positive 6. So they do mac correctly. And negative 2 minus 3 is a negative 5. So they ab correctly as well. So these are the numbers we're circling. Now, since we do not have to use the grouping box, we can go straight into our answer. Our GCF is 1, so I don't have to write anything on the outside. I'm going to go ahead and go to 2 sets of parentheses. Since I have the letter x, I just need to make sure I put an x in the front of both of these. And then I'm going to use my numbers from our half box. My minus 2 will go into that first set of parentheses, and then the minus 3 will go into the second set of parentheses. And these are your factors of x squared minus 5x plus 6. You can still use the box, the grouping box, if you would like to, but this is a shorter way of factoring these if you don't have to use the box. Example 5, 2x squared minus 9x minus 18. Again, the first step is your GCF. The smallest number is 2. 9 cannot be divided by 2, so automatically your GCF is not 2. Even though 18 can be divided, it has to be common. So 9 cannot be divided by 2. So the next number would be a 1. Everything can be divided by 1. GCF so far is 1. All of these do not have a letter, so the GCF is just 1. We look at our a value. Since the a value is equal to 2, we must use the grouping box. It will not be as easy as this last one where we can just put our numbers in. We have to use the grouping box. So go into the half box. Our mac, so a times c. We have a 2 times a negative 18, which is going to be a negative 36. And then our ab, so we want that b term, which is at negative 9. So we list out our numbers that multiply to 36. So that's 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, 6 and 6. So these are all the numbers that multiply to 36. Now we try and see if they can add to that negative 9. 1 and 36 will never give you a 9, so those are gone. 2 and 18 can never give you a 9, so those are gone. 3 and 12. If we do 12 minus 3, that's 11, 10, 9. But we want the negative 9. So if we have a positive 3 minus 12, that will give you a negative 9. 4 and 9, if we combine those, that will give us a 13, so not a 9, so these are gone. 6 and 6 will either give you a 0 or a 12, so it will not give you a 9, so those are gone. These are the only two that we can check if they completely macab correctly. So we mac 3 times negative 12 gives us a negative 36, which is what we wanted, and 3 minus 12 gives you a negative 9, so these numbers do macab correctly. And again, because A was 2, we have to use the box, the entire box. We cannot just put these straight into our answers. So we draw out our grouping box. Since our GCF was 1, we can put our original ax squared value inside of here. So we'll have our 2x squared. In the next box, we'll put our first number, that positive 3, with the letter of x. In the next box, we'll then put that negative 12 with the letter x. And in the last box, we'll put our c value, which again, because our GCF was 1, we can put our original c value of negative 18. Now we're going to factor out our GCFs. Okay, so going to that first row, going to the side, the first sign is positive. The GCF between 2 and 3 is a 1. And the GCF between x squared and x is an x, because they both have an x, and I always look for the smaller amount. On the next row, my first sign is negative. So I know this will be a negative. GCF between 12 and 18. So my smaller number is 12. 18 cannot be divided by 12. But then I know that 12 is 1 and 12, 2 and 6, 3 and 4. So my next largest number would be that 6. So 18 can also be divided by 6. So far our GCF has a 6 in it. They do not both have an x, so my GCF is just a negative 6. For that first column going to the top, my sign is a positive. GCF between 2 and 12, my smallest number is 2. 12 can be divided by 2, so GCF has a 2 in it. And then they both have x's. My smaller amount of x's is just 1x, so I can put 1x on here. So our GCF is 2x. The next set, my first sign is positive. GCF between 3 and 18. My smallest number is 3. 18 can be divided by 3, so our GCF is 3. They do not both have x, so then I do not put an x up here. Now I look to see, is my 2x a perfect square? I cannot take the square root of this, so no, it is not. So that means that this part is done. The 1x is also not a perfect square, so this next part is done as well. So we can put our answer in our two sets of parentheses. 2x plus 3 is our first set. And open up another parenthesis. Our next set is that 1x minus 6. So I can just put x minus 6. If you want to put the 1, you are more than welcome to. But these are our factors of 2x squared minus 9x minus 18. On this last example, we have 4mn squared minus 4m squared n squared plus m cubed n squared. So we have a lot of letters on here. So the first thing, our GCF. The smallest number is still a 1, so we know our GCF will have a 1 on it. Now we look at our letters. Now all of these do have letters. Let's make sure they have the same. This first one has an M, the second one has an M, and the third one has an M. So we can pull out an M, but how many? The smallest amount of M's that we have is just 1 on that first one. So we can pull out just one M. Then we look to see this one has an N, next one has an N, and the next one has an N. So we can pull out an N, but how many? N squared, N squared, and N squared. So the smallest exponent is a 2, so we can divide everything by N squared. This is our GCF. So remember, we have to divide everything on here by that 1m n squared. So 1m n squared. We're going to put that on the outside of our parentheses. Now 4 divided by 1 is 4. M divided by m is gone. n squared divided by n squared is also gone. So that just becomes 4. Then we have minus 4 divided by 1 is 4. M squared divided by m is m. N squared divided by n squared is gone. Then we'll have plus 1 divided by 1 is just 1. M cubed divided by m is m squared. And n squared divided by n squared is gone. So we have divided everything. We have now a trinomial in here, a quadratic trinomial. Let's rewrite this to make it in standard form. So I'm going to have this as 1mn squared as our GCF. We have a positive m squared, so that comes first. Then our m comes next, so that's a negative 4m. And then we have a constant of positive 4, so plus 4. This is now what we need to factor using macab. So we found our GCF, so we can go ahead and put over here that 1mn squared, and then I'm going to open up a parenthesis, because I know that that did factor for our GCF. So if this can't factor further, I still have it factored somehow, so it's not prime. So our a value on here is now 1. So we no longer have to use the box. So no box. No box. That means the no grouping box. We can just do our half box to do our macab. So our mac, a times c, that's a 1 times a positive 4, which is a positive 4. And then our b value on the side is that negative 4. What multiplies to 4 is 1 and 4, and then 2 and 2. Now we see if they can add to the negative 4. 1 and 4 will never be able to give you that 4, so these two are gone. 2 and 2, they become a 4. They can give you the 4, but we want a negative 4. So both of these signs, if they're negative 2 minus 2, gives you a negative 4. These are the only ones we have to check if it macabs completely. So mac, negative 2 times negative 2 is a positive 4. Negative 2 minus 2 is negative 4. So these do macab correctly. So with that being said, since we don't have to use the box, we can actually go ahead and put these into our answers. So we will have 2 sets of parentheses. So I'm going to come up here to where I already started part of my answer, because I put the GCF on the outside. Always put your GCF on the outside. Now the letter that was remaining inside of our quadratic is the m. So m has to go in the front of both sets. Now I put the numbers into both sets. So that first one is a minus 2, and the second one is a minus 2. So this is our answer. However, this can also be written a different way. We can keep that 1mn squared, because that's our GCF. But because these are the exact same thing, and they're multiplied to each other, this can be written as m minus 2 parentheses squared. Because that, whenever you multiply something by itself, you're just squaring it. So x times x is x squared. 5 times 5 is 5 squared. So anything times itself is that thing squared. So you can write your answer out like this, or like this. Either one is fine. I am going to make a little note down here to re-mention what I just said, that m minus 2 times m minus 2 can go as m minus 2 squared. But you also have to understand that it goes the other way too. If you're given m minus 2 squared, you can rewrite them out twice, because if you had to distribute them to get in a standard form, you have to make sure that you end up with a quadratic. What this also means, there's a specific terminology here. What we factored, the m squared minus 4m plus 4, this is what turned into that m minus 2 squared. It means that that m squared minus 4m plus 4 is called a perfect square trinomial, because it'll factor to something that we can write as squared.